Solve this system. As you solve for a variable, enter that value to check it. When you have found the entire answer, enter the full answer below as an ordered triple. So let's take a look at the system right here. As I'm studying the variables, I can see that these y's would be easy to eliminate in the first two equations here. So let's go ahead and do that to create a new equation 1 with two variables. So I'm going to add equations 1 and 2. So it's going to be negative of 3x plus y plus z equals 1, and then 2x minus y plus 4z equals negative 11. And we're just going to simply add these two equations, and we're going to get negative x, and then plus y minus y makes 0, and then plus z plus 4z is plus 5z, and then 1 plus negative 11 equals negative 10. So there's our new equation with two variables, negative x plus 5z equals negative 10. So now we need to create another equation using x and z as variables. So we're going to have to eliminate the y one more time. And we can't use these first two equations again. We have to use a different pair of equations. So I'll just use equations 2 and 3 here. So as I look at equations 2 and 3, if I'm going to add those, I'm going to need to multiply equation 2 by 4 to create a negative 4y plus 4y situation and eliminate the y's. So we need to multiply this entire equation 2 by 4. So 4 times 2x is going to be 8x. And then 4 times negative y is negative 4y. And then 4 times 4z is plus 16z, positive, equals, and then 4 times negative 11 is negative 44. Now I'm going to recopy this third equation. So it's negative x plus 4y minus z equals 14. Now we're going to add. So 8x minus x is 7x. Negative 4y plus 4y is 0, so the y's are eliminated. So 16z minus z is going to be 15z, and it's positive, so plus 15z equals negative 44 plus 14 is negative 30. So here we have two equations with the y's eliminated, and now we're going to need to eliminate another variable to solve for either x or for z. So I'm going to recopy the first equation down below. So it's going to be negative x and then plus 5z equals negative 10. So looking at these equations, if I were to multiply this second equation by negative 3, I could eliminate the z's. You could also multiply by 7, but I'm going to multiply by negative 3. It's a smaller number. So I'm going to recopy the first equation. I'll do that up here. 7x plus 15z equals negative 30. And then I'm going to multiply negative 3 times the second equation here. So negative x times negative 3 is positive 3x. Negative 3 times positive 5z is negative 15z. And equals negative 3 times negative 10 is 30. So now we can add 7x plus 3x is 10x. 15z minus 15z, that's 0 z's, so the z's are eliminated, and then equals negative 30 plus 30, which is 0. So 10x equals 0. Divide by 10 to solve for x, and you get x equals 0 divided by 10, which is 0. So x equals 0. Okay, now we're going to back substitute to solve for the other variables. I can back substitute into one of these equations here, the x and the z equations, to solve for z. So let me substitute into the second equation here. So it's going to be negative of 0 plus 5z equals negative 10. So the negative of 0 is just 0 plus 5z equals negative 10. So you can ignore this 0. 5z equals negative 10. Divide by 5, both sides. So z equals negative 10 divided by 5, which is negative 2. So z is negative 2. Now I need to solve for the y. And I could do that by substituting into any one of these three equations that we started with. I'm going to use the first equation. So it's going to be negative 3, and I'll substitute the 0 for x, plus y, we don't know that one, plus, and then z is negative 2, so negative 2 goes here, equals 1. So negative 3 times 0 is simply 0, plus y, plus negative 2, that's a double sign situation, so it's just minus 2, equals 1. And we can ignore the 0, so it's simply y minus 2 equals 1. Add 2 to both sides. We get y equals 3. Okay, so there's the solution. The ordered triples 0, 3, negative 2.